Okay, so for this one today, should be number 17. The matrix multiplication. And again, two parts on this. And the very first thing we're going to look at is the kind of easier part, is what we call scalar multiplication. And it's basically, it's like scales, that it's just or dilations if you're going through these. So basically is this, that if matrix A is a 2 by 2 matrix, which 1, negative 3, 5, 0. That scalar multiplication is basically, they're going to give you some number, some scale factor that you're going to take this matrix and multiply by. So if they ask you to find 3A, then we're going to take every single number that's in A and multiply it by 3. So take every number in here and multiply it by 3. So it's going to be 3, negative 9, 15, and then 0. Okay. Now, what they'll do with that one is, this is where they're going to tie it back into what we're doing yesterday. They're going to take some scalar multiplication like we have here, and then they're going to have you do some other stuff with it. So it may be something like this. They may ask you to find 2a minus 3b. So you're going to have to do some scalar multiplication, but then you're also going to have to add and subtract when a is 2, 8, negative 3. Negative 1, 5, 2. And then matrix B, negative 1, 0, 5, 0, 3, negative 2. Okay, and again, we're going to do 2a minus 3b. So what we're going to do is we're going to go ahead and figure out what 2a is. So we're going to take every single number that's in a and multiply it by 2. So that's going to make it 4, 16, negative 6, negative 2, 10, and then 4. And then we're going to take every number that's in B and then multiply it by 3. So that's going to make it negative 3, 0, 15, 0, 9, and negative 6. Okay, so again, this is where they're going to tie in the addition and subtraction we were doing yesterday along with the scalar multiplication today. So if it was 2a minus 3b, take everything in matrix A and double it. Take everything in matrix B, multiply it by 3. And after you've got those two numbers, now we can go back and subtract these two matrices. So for subtraction, it's 4 minus negative 3. It's 16 minus, now 16 minus 0, we can do that. That's just 16. It's negative 6 minus 15. It's negative 2 minus 0 on the bottom. So again, it's negative 2 minus 0 doesn't change anything, so that's just negative 2. It's 10 minus 9, which is 1. And then it's 4 minus negative 6, See that part? So again, with it being 4 minus -3, that's 4 plus 3, so that would be 7. Again, we did 16 minus 0, which is 16, so nothing there. -6 minus 15 is a -21. -2 for that one. We had 1 there. Again, 4 minus -6 is really 4 plus 6, which means that would be 10. So here's the second part we'll do with this one. Now, still kind of still the first thing, just a little tweak, a little twist to it here. So for this one, we're going to solve a matrix equation. And the big thing is that, if we were solving like normal equations, it would be something like this, where you had like 3x minus 2 equals 17. If it's a matrix equation, here's the difference though. Is now you're going to have a matrix where instead we had just numbers, now you're going to have a matrix in there. Okay, so first thing we're going to do before we do anything is go ahead and do this scalar multiplication you've got here. So go ahead and do 2 times -1, 2 times 5, 2 times 7, and then 2 times 0. So for now, ignore everything else, and where you've got this scalar multiplication, go ahead and do that scalar multiplication. Okay, now the other stuff that's around it, that's where we're going to bring that in. We've got the 3x here minus this equals this matrix over here. Okay, now, and let me back up for just a second for this part of it. If we were going to solve an equation, before we had it kind of written out like it was an equation without the matrices here. If it was 3x minus 2 equals this thing over here, what would we do to solve that equation? If it's 3x minus 2, what's our next step? Yeah, if it's 3x minus 2, your next step would be to add 2 to both sides. So just like this is 3x minus this thing in here, we're going to do plus that thing to both sides. So we're going to add this matrix over here, and then we're also going to add that matrix over here. Because again, if you've got a plus something and a minus something, those two things cancel each other out. So once we do the plus and minus on this part, all this just kind of goes away. So they'll leave you with 3x equals. And then now that we've got this one, so these two things are canceled out. Now we're just going to add these two matrices over here together. So it's 17 plus -2, which is 17 minus 2, which is 15. It's -13 plus 10, or 10 minus 13, which should be a -3. 14 minus -7 plus 14, or 14 minus 7 would make that 7. And then at the end, very nice, you got 0 plus 0, that's still 0. Okay, so just like you would do with a normal equation, if it's 3x minus this thing, if it's minus this thing, you're going to add that thing to both sides. And then if it's 3x equals this part over here, if it's 3 times x, then our next step would be to divide it by 3. So then we're going to take every single thing in here and divide it by 3. So we're going to divide this by 3, we're going to divide this by 3, we're going to divide this by 3, and divide that by 3. So if we took 3x divided by 3, we got to take every single number and then divide them all by 3. Okay, 15 divided by 3 is 5. 3 divided by 3 is 1. We got 7/3 and then 0. Okay, so we're still looking for x, whatever variable they give to us in this case. But now instead of just being a number, now it's going to be a matrix as we go through this thing. It's a block of numbers, if you want to think about that way. Okay. Okay, so that's all the scalar multiplication. And again, this is of the ones we're going through. That's going to be the tougher part. Of those that we're going. If it's just the regular scalar multiplication like they are back here, again, you just take some matrix and you just make it 3 times as big, or you multiply it by, -4. They give you some number and you multiply it. This was making you kind of solve an equation where you're kind of doing a little bit of both here. Okay, and then the last thing, the second part of the thing we're doing today, this is where we're going to go back to this handout that I gave to you. So this is where we're doing like regular multiplication. So to multiply one matrix by another matrix, the very first thing you've got to do is you've got to make sure that you can actually do this. There are certain sizes of things that you have to make sure that it fits on this part. Just get this back. Okay, so to multiply one matrix by another matrix, you got to check and see if you can do this, because you cannot multiply all matrices together. Depending on the size, some of them don't work. So basically, here's what we're going to do. You got to be able to kind of recognize what size matrices are. So let's say we're going to multiply A times B. It says, can you multiply A times B? So basically, here's what you do. Matrix A is a 2x4 matrix. Matrix B is a 4x3 matrix. And here's all you have to do if you can get the sizes. As long as these two sizes are the same, then yes, you can. So if the middle two numbers match up, if these are the exact same numbers, then yes, you can multiply these two things together. So that part would be that yes, you can. And then whatever numbers you have it together, so that's what's in the middle. So that's kind of the connector pieces. Whatever's left on the outside, then that's going to be the size of the next, or the answer that you're going to go with. So if it's a 2x4 matrix and a 4x3 matrix, if you multiply these two together, you can, because the two numbers in the middle are the same. The answer is going to be whatever's left over on the outside. So it's going to be a 2x3 matrix. Okay, now it says reverse it around. What if we do B times A? It's 4 times 3, or 4x3 by 2x4. Check your numbers in the middle. These are different. So no, you can't. So if they're the same, you can. If they're different, then there's no way you can multiply those two things together. Okay, and then to multiply matrices, says here's what we're going to do. We're going to take every row of the first matrix and multiply by every column of the second matrix. And remember, rows go this way, and then columns go that way. So if you're doing a row, you're going side by side. If you're doing columns, then you're going up and down. Okay, so what we're going to do, we're going to run through some examples on going through some multiplication, letting you see these. We'll throw you 3 or 4 different ones out there. Cause some of them are easy to see, some of them are a little harder to see. And we'll just kind of practice through those just to make sure everybody kind of understands, what we have and what's going on as we go through all those parts and pieces. Okay, so for first example, to multiply together, let's go with matrix 1, or matrix A is 2, 1, -3, 0. And matrix B is going to be negative 1, 3, and then 0, 4. Okay, again, what we're going to do is we're going to take every row of the first matrix, which means we're going to go this way. So we're going side by side. We're going to take this row and we're going to multiply it by this column. Okay, and again, if we're talking about the size on this one, this is a 2 by 2 matrix. This one's a 2 by 2 matrix, so it's easy because everything is 2 by 2. We got 2 rows and 2 columns, so the 2's in the middle match up, and we're doing everything that's there. So we're going to find AB. Okay. Okay, so when we multiply the first row by the first column, basically it's going to look like this. So we're taking 2, 1 and multiplying it by negative 1, 0. And when you do that, you're going to take the first number here and multiply it by the first number here. So that's going to be 2 times negative 1. And then you're going to add that to the second number here times the second number here times 1 plus 0. So that's negative 2 plus 0, which is negative 2. Okay, now, and this was something I had never thought about this before. As you're going to write out your answers, if you take your second answer, your second matrix that's here, we're going to write our answers underneath this one. So if we take this row and multiply by this column, whatever the answer is when we do this one, write it underneath the columns here. So if this is going to go here, that negative 2 is going to go right there. And then when we take this row and multiply it by this column, then that answer is going to go underneath it here. So when we do 2, 1 and multiply it by 3, 4, that whatever the column is, we're going to put that answer right here because columns are kind of going up and down. So if we go up and down, that's going to tell us all of our answers are going to be right here. So we're going to do 2 times 3 and then plus 1 times 12. So that was out of the second column, so that one's going to go right there. Okay, so again, it's this row times this column, the answer goes here. This row times this column, the answer goes there. Okay, and then we're going to go to the second row, and now we're going to multiply it by the first column, and same thing, that answer is going to go underneath it. Now it's going to go down right here. So we're going under this one, so we're going to put this answer here. So it's negative 3, 0 times negative 1, 0. So it's negative 3 times negative 1. I'm going to add that to 0 times 0, which is good because that's just negative 3 times negative 1. That's just going to be 3. We add 0 to it, it's still just 3. So that's going to go there. Okay. And then we'll do the same thing here. We're going to take this negative 3, 0. Now we're going to multiply it by 3, 4. So we're going to do negative 3 times 3. And then we're going to do 0 times 4. That's negative 9 plus 0, so that's just negative 9. Again, whatever column you're underneath when you go for this one, that's going to tell you where the answer is going to go there. So you get to use your second, whatever two matrices you're going to multiply together. The second one is kind of going to line everything up. That whatever column you use, that's going to mean if you use this column, the answer is going to go underneath here. If you use this column, the answer is going to go underneath here. If it's the first row, it's on top. If it's the second row, it's the second one there. If there was a third row that was here, those answers would go down here. So they always kind of, if you think about your columns, it's always going to point down to your answers if you go through those. Okay. All right. Now let's give you one that's a little different size because that sometimes the 2x2, sometimes the 2x2s like this can be. Some people think it's really easy. Some people think it's a little bit confusing. We'll kind of give you one that's a different one that doesn't look anything at all like those two. Give you something that look totally different as we go through this one. Okay. If you want to do this on the back of it, you can. Again, if you're on a separate sheet, you can do that. Yeah, I'm just writing big just because it's easier for me that way. All right, so this one, let's go. Matrix X is 10, 1, 0, 9, 6, 0, 0, 5. And then Y is 6, 3, 2, 1. Okay, now, and there will be some questions, homework and test. It's going to be that before it even asks you to do anything, it's going to ask you, can you find X times Y? And that basically means you got to make sure that the sizes match up to get these. So for this one, again, you got to think that it's rows by columns. So we've got 1, 2 rows. We've got 1, 2, 3, 4 columns. So it's a 2x4 matrix. This one, we've got 1, 2, 3, 4 rows. And we've only got one column, so it's a 4x1 matrix. Okay, so if we're going to find X times Y, it's 2x4x4x1. Again, these two numbers in the middle are the same. So can we find X times Y? Yes, we can. Again, the answer size will be whatever's left over. It's going to be a 2x1 matrix. Okay, and again, it seems like it's a small thing, but you've got to get used to being able to find out what the sizes are of these. If you can figure out the sizes, then everything else will kind of, be able to spin off from that one as you go through those. Okay, so now we're actually going to multiply this because we know we've got this one. We're going to actually go ahead and multiply these out. So again, if we'll go through this one, we're going to take this row times, now there's only one column, so we're going to take everything there and multiply it by this. So it's 10, 1, 0, 9 times 6, 3, 2, 1. Okay, so 10 times 6 is 60. 1 times 3 is 3. 0 times 2 is 0. And 9 times 1 is 9. So that's 63 plus 9, which would make it 72. Okay, and again, I hadn't really thought about this one until we're going over this one this morning with the other class. As you're multiplying these together, take the second matrix And this is going to tell you how many answers you need column wise. So in this case, we did that. We've got 72. There's no other column. So basically, again, we know it's going to be there. So that 72 is going to go there. Because there's not another column, so there's nowhere else for it to go. So we're only going to have one column of answers as we go through this one. To get the second answer, now we're going to take 60005 and multiply it by 6321. Okay, so again, we're going 6 times 6 for 36. The good thing it was zeros. If we do 0 times 3, that's still 0. If we do 0 times 2, that's still 0. And 5 times 1 is 5. Add all that together, that's 41. So 41 is going to go there.